Hello there, welcome to the Year 9 Test 2 revision video. So in this revision video we're going to be doing lots of questions to get you really good at Pythagoras, trigonometry and similar triangles. So at each question I'd like you to pause the video and answer the question. Have a proper go at the question, try really hard, don't just give up after 20 seconds. Then play the video to see if you were correct, and if you weren't then try to remember what you needed to do to make sure you can do it next time, and try the question again maybe the next day to see if you get the question correct next time. So we're going to get kick started with Pythagoras' theorem, pause the video and give these two questions a go. Okay, so with Pythagoras' theorem it's really important that you identify which side is the hypotenuse. It will always be the diagonal side that is opposite the right angle, so that's the hypotenuse side. Because when we use Pythagoras' theorem, a squared plus b squared is c squared, you must always put the hypotenuse where c is in the formula. It doesn't matter where a and b go, i.e. the 5 and the 9, but the hypotenuse must always be c. So it's going to be x squared, 5 squared plus 9 squared. So either one of these two can be a and b. Then we reach for our calculator and we type in 5 squared, so that's 25. 9 squared is 81, that's x squared. Add these two things together, and we get 106 equals x squared, and then we square root that final answer and we get 10.30, so 10.3. I'm going to do all of my answers here to 3 significant figures. I would advise you do the same when you get to the test. Okay, let's move on to the second one now. If you've not done the second one, pause it and have a go. In this one, the 8 side is the hypotenuse, so when I get to using a squared plus b squared equals c squared, the 8 must be in the c position. Doesn't matter what way round the other two values are, so I'm going to put that as 4 squared add y squared. 4 squared is 16, add y squared equals 64. In this question we need to move the 16 onto the other side by subtracting it, so take away 16 onto the other side. So 64 take away 16 is 48. And then when we square root that answer and we write it as a decimal, we're going to get 6.93. So 3 significant figures. So there we are, that's the answer for that set of questions there. Okay, if you need some extra practice ones, then go ahead and answer these 2 questions here. Okay, so in this question here, it's a bit more difficult to tell which side's the diagonal side. It's always going to be the one that's not connected to the right angle. So it's this side here in this question. So when we use a squared plus b squared equals c squared, we're going to put 11 squared over here, and then it'll be 4 squared add x squared. So that's 16 plus x squared is 121. Take away the 16 to the other side, and we get 105. And then we square root that answer and we get 10.2. There we are, or centimetres. There we are, so that's the answer to that question. In this question here, the hypotenuse is the one not connected to the right angle. This one and this one are connected to the right angle. It's opposite it, so it's the hypotenuse is y. So a squared plus b squared equals c squared. So that's 7 squared plus 17 squared equals y squared. 7 squared is 49. I don't know 17 squared though, so let's type that in. 289 equals y squared. Add those two numbers together and you get 338 is y squared. And then we're going to square root that answer and we get 18.4. Y equals 18.4 centimetres. So there we are, that's the answer for that set of questions there. Okay, so in these two questions here, I've not written down what the question says, but in these two questions, what you've got to check is, are these two questions right angle triangles, and prove it. So prove if these two triangles are right angle triangles. Pause the video and give these two a go. Okay, so to prove that two triangles are right angled triangles, we need to prove that a squared plus b squared does equal c squared. And if the two things are equal, great, it's a right angled triangle. And if the two things are not equal, then no, it's not a right angled triangle. So let's go 5 squared add 12 squared equals 13 squared. This is definitely the hypotenuse over here, the one not connected to the potential right angle. So 5 squared is 25. 12 squared is 144, and 13 squared is 169. If we now add together that left-hand side, we get 169 equals 169. Ah, great, so these two things are equal, so yes, it is a right-angled triangle. Okay, so if you didn't know how to do the first one, now you know how to do it, so have a go at the second one. Okay, so in this second question here, this one's the hypotenuse, so it's going to be a squared plus b squared is c squared, and 6 is going to go where the c squared is. It'll always be the highest number, so 6 squared will go there, and that's 3 squared and 5 squared. Okay, so that's 9, 25 equals 36, and 9 add 25 is 34. So that's not equal to each other, so I can put a little dash through there. This is the symbol for not equal to in maths. So in that case, no, the triangle does not have a right angle. Okay, so there we are. That's how we do those two questions there. Okay, some trigonometry now for you, everyone. So pause the video and give these two questions a go. Right, okay then, let's get started on these two questions here then. So from the beginning, what we have to do first is label the sides on our triangle. So we know how to label the hypotenuse on both of them. That's pretty straightforward. And then the other labels are opposite and adjacent. You need to find the opposite side to your angle, not the right angle, the angle that you're given. So if you were to stand in this, if this was a triangular shaped room and you were where the angle is, what would be the opposite wall? It would be this wall over here. So this is the opposite side, and this side here is called the adjacent side. It always depends on where your angle is, which one the opposite side is, which one the adjacent side is. So in that case, we now know that we're going to work with the opposite side and the adjacent side for this question. Now we need to remember which piece of trigonometry we're going to use. We can work that out by remembering our formulas, and we can remember our formulas by remembering SO, CAR, TOA. So we would use sine if we had the sides opposite and hypotenuse, we would use cos if we had the sides adjacent and hypotenuse, and we would use tan, like in this question, if we have opposite and adjacent. So the way we do that is we identify that this question is a tan question, and we write out tan of the angle, whichever angle, whatever the value of your angle is, equals a fraction. And in this case, the fraction is opposite on top because it's the first letter out of O and A. So O will go on the top and A will go on the bottom. So what's really helpful about SOHCAHTOA is that the fractions go in the right order. So for sine, it's opposite over hypotenuse. For cos, it's adjacent over hypotenuse. And for tan, it's opposite over adjacent. This is where we now need to reach for our calculator. So tan 23 is 0.424 equals x over 8. And then we're going to press, now we've got a little equation. we've got 0.424 equals x divided by 8. Now to move that 8 to the other side, currently it's being dividing x, so we're going to need to times 8 to move it to the other side. So we're going to times the other side by 8 to make the equation balance. So we're going to take that value that's on our calculator already by pressing answer on our calculator and times it by 8, and we get 3.40 to 3 significant figures. And that's a difficult one to round because you'll need to look to your fourth significant figure, that's a 5, that will round the 9 up to another 10, which will make the 3 a 4. But when you have 3 significant figures, you must always write all of your 3 figures, even if the last one's 0. Right, so now you know how to do it. So feel free to now pause the video and give this second one a go. Okay, so here is where our angle is. So the other side of the triangle, that's where your opposite side is. This is the hypotenuse, and this side up here that's next to the angle is the adjacent side. So in this question, we're working with the opposite side and the hypotenuse side. So I know out of SO, CAR, TOA, I need the one with O and H in it. So that's SO. So that means we're going to use the sine function. Although it says sin, you're going to pronounce it sine. So sine of 55 equals, now we need to make sure our fraction is in the right order. So opposite goes on the top, so that's 6, and hypotenuse goes on the bottom, that's y. This is a little bit more of a difficult one to rearrange because our y is on the bottom. So we type into our calculator sine 55 and we get 0.819 equals x over y. Then we multiply the y onto the other side, like we've got a little equation here. So 0.819y equals x. Then we're going to divide by this difficult number 0.819. So divide by 0.819 on both sides. Now currently that is still in my calculator. So I'm going to press 6 divided by answer to make sure my answer is as accurate as it can be. The answer to this question, therefore, is 7.32 centimetres. Both of them are centimetres. Excellent. So there we are. So that's your first set of trigonometry questions. Have another go, see how these ones go, get some more extra practice in, pause the video and give these 2 questions a go. Right, okay, let's get started on these 2 questions here then. So we have the hypotenuse, which is 9. The opposite side of this triangle is where the opposite side is, and this side here is the adjacent side. So we're going to work with the trigonometric ratio that has adjacent and hypotenuse in it. So out of SO, CAR, TOA, we want A and H to be in the ratio, so that's CAR. So we're going to write cos 64, close brackets, equals adjacent over hypotenuse, because it goes A then H, so x over 9. Type in cos 64 into your calculator and you get 0.438 equals x over 9. And then the way we're going to get that 9 onto the other side, currently x is dividing 9, so the opposite of that is timesing by 9. So answer button times 9 is 3.95. There we are, that's the answer to that question there. On to the final one of trigonometry here. So we're going to put that side as the hypotenuse. From where the angle is, this length over here is the opposite side, and the side left over is the adjacent side. So out of SO, CAR, TOA, we want these 2 sides here, so that's opposite and adjacent, so that's tan. Tan 40 equals opposite, which is 7 over 9. So let's type into our calculators then. Tan 40 is 0.839 equals 7 over y. This one a bit more difficult because y is on the bottom. When we do this, we have to multiply the y onto the other side. And then we divide this 0.839 number onto our other side. So I need to now do 7 divided by 0.839. Now 0.839 is currently in my calculator, so I'm going to press 7 divided by answer, and that gives me 8.34 centimetres. There we are, so that's the answer to these two questions. Alright, so now we're going to do some trigonometry where we need to find the angles. Pause the video and see if you can remember how to do these questions. Okay, so the first process is still the same. We need to label our triangle correctly. So that side there is H. Here's where our angle is. So the other side of the triangle, that's the opposite side. And this side here is the adjacent side. So out of SO, CAR, and TOA, we need to use the trigonometric ratio that is opposite and adjacent, which would be tan. So in this sort of question, we write tan x equals, now we need to create the fraction the right way around, opposite over adjacent, so 5 over 11. And then to work out the angle x, you've got to do tan minus 1, 5 over 11. Now that will usually involve pressing shift on your calculator and then the tan button, and that will give you tan to the power of minus 1. Then after that, you'll type your fraction into the calculator. You can either type it in using the fraction button or type in 5 divided by 11, but close the brackets and you'll get 24.4 degrees. So there we are. So now that you know how to do it, have a go at the second one. Okay, so in this question here, we've got hypotenuse. This side would be the opposite side, and this side here would be the adjacent side from where the angle is. So out of SO, CAR, and TOA, we've got the hypotenuse side, and we've got the adjacent side, so it's cos for this one. So we're going to write cos y equals, and then getting the fraction the right way round, adjacent over hypotenuse, so 8 over 14. Now we're going to do cos minus 1 of 8 over 14. So shift cos, 8 divided by 14 is 55.2 degrees. And there we are, so that's the answer for that question there. Okay, so if you didn't get those first two, have a go at these two questions here. Right then, so let's go through this a little bit quicker then. So this side here is the hypotenuse, this side up here is the opposite side, and this side here is the adjacent side. So we want to look for the trigonometric ratio that has A and H in it, and out of SO, CAR, TOA, you've got to go for the cos one because it has adjacent and hypotenuse in it. So it's cos x equals, then getting the fraction the right way around, adjacent on over hypotenuse, 3 over 7 is equal to, so now we get x is cos minus 1, so you press shift and then cos 3 over 7, and you get 64.6 degrees. And for the final one here, so we're going to label this side hypotenuse, this side opposite, and this side up here adjacent. So we need now the trigonometric ratio that has opposite and hypotenuse in it. SO, CAR, TOA. So that's opposite and hypotenuse, so it's definitely SO. So that means sine y equals, get the fraction the right way around, opposite over hypotenuse, 6 over 13. So now we need to do sine minus 1, 6 over 13. So that shift sine 6 over 13, and we get 27.5 degrees. Okay, so there we are. All right, bit of problem solving now. So in this question here, you've got to work out the area of the triangle. Pause the video and see if you can remember how to do these sorts of questions. Right, okay, so to work out the area of a triangle, you need base times height divided by 2. That's the formula. But make sure that when you have the height, it is the perpendicular height or the straight up height, not a diagonal height like this 20 is. So at the moment, we've not worked out the height of this triangle here. That length there would be the height, and the base is 10. So what we need to now do is to use Pythagoras' theorem to work out the height. How do we do that? Well, if we visualize that we've got a right-angled triangle here, and we've got 20 on the hypotenuse, we'll have to divide the base into 2, making it 5 centimeters. Now we could use Pythagoras' theorem to work out the height of the triangle. So it's going to be a squared plus b squared is c squared. Which side is the hypotenuse? Well, the diagonal side, or the side not connected to the right angle, is always the hypotenuse. So 20 is going to go on this side. 5 and h are going to go on this side. So it's 25 add h squared is 20 squared is 400. Yeah, 400. Take away that 25 on the other side and you get 375. So therefore h, just on its own, square root of 375 is, as a decimal, 19.4. Fantastic. Now we know the height of the triangle. So now when it comes to working out the area of the triangle, and we use base times height divided by 2, the original base of the question was 10, so 10 all across that base, times the 19.4 that we had before, divided by 2. Now when you type it into the calculator, don't type in 19.4, because what you should now have on your calculator is the 19.36491673 that's on your calculator from the question, the part of the question before. So use answer button at that point. So fraction button, 10 times answer divided by 2. And if you write that as a decimal, you get 96.8. Now, what would the units be for this question? It's an area, and our dimensions are in centimeters, so centimeters squared. Okay, so that's how we do that sort of problem there. Okay, so if that now makes sense, have a go at this new question. Okay, so again with this question here, we're going to divide the shape in 2 to work out the height, and we're going to work out the height by doing Pythagoras theorem on this left-hand triangle. You could do it on the right-hand triangle, it doesn't matter. I'm going to do it on the left. So that means we need to cut the base of the triangle in half to 4, and now we're going to do Pythagoras' theorem, a squared plus b squared equals c squared. So which side is the hypotenuse? Well, here is the right angle, so it's the side opposite to that, or not connected to it, and so the 8 squared must go on that side, the 4 squared and the h squared must go on this side, so that's 16 add h squared is 64, take away the 16 on the other side, and you get 40, so 64 minus 16 is 48, square root that number, and as a decimal it's 6.93. So now we're going to work out the area of the whole triangle by doing base times height divided by 2. So that is the whole base of the triangle, which is 8, times the height of the triangle, which is 6.93, although you're going to be pressing answer button at that point, divided by 2. So fraction button, 8 times answer divided by 2. If you don't have a fraction button, just type in 8 times 6.93, so 8 times answer button divided by 2. That should all work as well. And you'll get 27.7 centimeters squared. And there we are, that's the answer for that problem solving question. Okay, another problem solving one here. Work out the length of the diagonal in this rectangle. Pause the video and give this question a go. Okay, so let's work out this diagonal here. It's much easier if we draw the diagonal like this, because we can now much more quickly identify that that is a right angled triangle here. So we want to work out this side here. If we don't have a value in maths, we'll call it x. So it's Pythagoras' theorem again. A squared plus b squared is c squared. So we've got 5 as one of the sides, 12 as the other one of the sides, but the hypotenuse is definitely x. So that's x squared. Let's now calculate it as 25 at 144 is x squared. That's 169 equals x squared. So x equals 13 centimeters. So there we are. That's the answer to that question there. Okay, have a go at this one here then. I've shown you how to do it. Have a go at another one. Okay, so let's draw that diagonal in, and let's draw the right angle triangle around it. So it's going to be, we don't know this diagonal, so we'll call it x. So we're going to use Pythagoras' theorem, x squared plus b squared equals c squared. So that's 6 squared add 15 squared add x squared. So that's 36 add 15 squared is 225 equals x squared. Add these two together, and you get 261 equals x squared, and then we're going to square root that answer, and as a decimal, it's going to be 16.2 to 3 significant figures. Centimeters. So there we are. That's the answer to that one. Okay, another problem solving one here. So a bit of trigonometry or Pythagoras. I can't quite tell which one. You'll have to work that one out in this problem solving question. So pause the video and give this question a go. Okay, this is a pretty tricky problem solving one. It will have taken you a long time to do this one here. So what I'm first going to look at is this left-hand triangle here. We've been given some information about this left-hand triangle, and we want to work out x on this side here. We're not given any of the angles on the other side, so we'll need to know both this side and this side to then work out this side to then work out x. In fact, let's not call that x, let's call that u. So the first thing we'll do is we'll work out u, which is this side here, the middle length, not the middle length, but the length sort of in the middle-ish of the shape. So in this question, we've got the hypotenuse. This one is the opposite side. So we're working with sine in this question. So sine 35 is opposite over hypotenuse. So that's u over 15. Sine 35 is 0.574 equals u over 15. Then we times the 15 to the other side, and we get 8.60 equals u. So u in the middle here is 8.60. Okay, so looking at the right-hand triangle now, we've still only got one side out of the two that we need to answer this question. So therefore, we're now going to need to work out the bottom side here. And I suppose now that we've got 8.60 on this side, we could use Pythagoras' theorem to work out the bottom side. 15 is the hypotenuse, so we'll make sure that goes where c is in the formula. So 15 squared here, 8.60 squared here, and y squared here. Now, you've got to remember the 25 is not going to be the base of the left-hand triangle, it's the base of the whole thing. So it's not y, so I'll have to work out y myself. So 8.6 squared is 74.0 plus y squared equals 225. Subtract the 74.0 to the other side, and you get 154.0 250.97 blah blah blah, and then square root that answer, and you get 12.3 centimeters to 3 significant figures. Okay, so if now this side is 12.3, then this value here must be what's left over from 25. So 25 take away the 12.3, and that side here is 12.7. Hopefully that makes sense. We've got 25 here. We've got 12.3 that is the left-hand section, so 12.7 is the right-hand section. It doesn't look like it to the diagram. Maybe it's a bad diagram. The final thing to do is now work out this final side here. And again, that's going to be Pythagoras' theorem. So a squared plus b squared equals c squared. So x is the hypotenuse in this question. We'll have 12.7 squared add 8.6 squared. So answer button squared, add 8.6 squared. I'm gonna add all of that together straight away. So I'm going to do the whole of that calculation there as 235.5 dot 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 equals x squared. And then we're going to do square root answer 15.3. And there we are. That's the answer to this really long problem-solving question here. All right then, so let's move on to the next question. Okay, it's a similar one, so have a go at this question here. Okay, so in this question we've got to work out what x is equal to. So let's first of all work out what this middle side here is. We need to use trigonometry to do that. So we've got the hypotenuse side here. We've got this is the opposite side comparative to where that angle is, and this side here is adjacent. Well, we don't know what this middle length is, so we'll call it y. So in this question we're working with O and H, so that means it's a sine question. So sine 28 equals y over 16. Sine 28 is 0.469 equals y over 16 times the 16 is the other side, and you get 7.51 equals y. Great. So now this is 7.51. The final thing to do will be to use Pythagoras' theorem to work out this side here. So it's a slightly easier question compared to the last one. A squared plus b squared is c squared, so 7 squared add 7.51 squared, but I'll use answer button at that point. So 49 add 56.4 equals x squared. Add these two things together and you get 105.4 equals x squared, and square root answer, and that's 10.3 to 3 significant figures, so 10.3 centimeters. Excellent, so there we are, that's the answer to that question there. Okay, so another problem-solving one here to do with Pythagoras or trigonometry. We've got to calculate the distance between the two coordinates 4, 6 and minus 9, 2. Pause the video and give this question a go. Okay, so let's go through this problem here. So we've got to calculate the distance between the two coordinates 4, 6 and minus 2, 9. I'll show you a diagram to explain the method to you, but then I'll explain how to do it without the diagram. So we want the coordinate 4, 6, so this is 4 across 6 up, and minus 2, 9 on that coordinate there. Okay, so we want to find the length of that line there. So what we're going to do is we're going to make a triangle out of this and work out how far left and right we need to go between the two coordinates and how far up and down we need to go between the two coordinates. Now to work out how far you have to go left and right to get between the two coordinates, you look at the x coordinate. One is at 4, one is at minus 2, so the base there is definitely 6. And to work out the height of the distance between the two coordinates, you look at the y coordinates. So between 6 and 9, that height is 3. So what we're now going to do is a Pythagoras calculation. In fact, a squared plus b squared is c squared. Now we're working out the hypotenuse, so the 3 and the 6 are definitely going to go on this side, x squared. So let's type that all into the calculator. 3 squared plus 6 squared, square rooted. That gives an answer of 6.71. And there we are. That's the answer to that question there. Okay, so if you didn't get it that time round, have a go at the next one, pause the video and give this one a go. Okay, so without having to draw the diagram, let's work out how far left and right these two coordinates are of each other by looking at the two x values. So between 5 and -3, that is 8. And let's work out how far up and down these two coordinates are from each other. So from -2 to 6, that's also 8. So add 8 squared equals x squared. You'll always be working out a hypotenuse because the x coordinates will tell you how far left and right, and the y coordinates will tell you how far up and down. So 64 add 64 equals x squared. That'll make it 132 equals x squared, and the square root of 132 is, 64 add 64. Oh, sorry, it's 128, not 132. And then square root that answer, and we get 11.3. Apologies for that mistake. There we are. The answer is 11.3. Okay, let's move on to doing some 3D Pythagoras and trigonometry work. So pause the video and give these two questions a go. Okay, so in the first question here, part A, we have to work out the length from A to G. Now this is a three-dimensional diagonal because it goes from the bottom left front corner to the back top right corner. And to work out a three-dimensional diagonal, the formula is a squared plus b squared plus c squared, because you'll have 3 dimensions here, and then you have to square root it all. So let's do that calculation for this question here. So it's going to be 10 squared, add 12 squared, add 30 squared, using all 3 numbers on the diagram. And we'll type that all into the calculator all in one go. Do as best as you can to type that all in. And as a decimal, you get 33.8 centimetres. And there we are. That's the answer for part A. Moving on to part B now, calculate angle GAC. So to work out which angle this refers to, you start your pen at the first letter, then you go all the way down to the second letter, and then you go to the third letter. And whatever angle you've made by your pen, that's the angle you've got to work out. So let's call it X. Let's draw this line out again. So I'm redrawing it out now. We've got X here. We've got 30 on this side here because there was 30 on this side here. And we knew from before in the question that this diagonal side is 33.8. This is a right angle triangle when we're now doing trigonometry. What sides have we got? So we've got the hypotenuse, so the hypotenuse is over here, and the opposite side is over here, and the adjacent side is over here. So out of SOHCAHTOA, we are doing a SO question, or a sine question. So sine x equals opposite over hypotenuse. And then what we need to type into the calculator there is sine minus 1, 30 divided by 33.8. Now currently, that value there is the answer button in my calculator. So I'm going to press answer button at that point. So sine minus 1, fraction button, 30 over answer value. And I get 62.5 degrees. And there we are. That's the answer for that question there. Okay, if you need another practice at one like that, then pause the video and give this one a go. Okay, so in this question here, we're working out the length from A to G. So that means we need to do the calculation of a squared plus b squared plus c squared, all square rooted. So that's going to be 6 squared, add 7 squared, add 16 squared. Let's type that all into the calculator all in one go. And we get the square root of 18, so not square root of 18, the value of 18.5 centimetres. Excellent. Now we're going to work out the angle GAC, so G to A to C out of this triangle here, so we'll call that angle X. Let's redraw that triangle out just so it's really easy for us to see the values we're working with. Here is X, on this side here is 16. I've just worked out that that diagonal side is 18.5. So again, it's going to be opposite and hypotenuse, so sine X equals, make sure the fractions right around, opposite over hypotenuse. So therefore x is equal to sine minus 1, 16 over 18.5, but that denominator is in my calculator as the answer value at the moment. So 16 divided by answer, and I get an answer of 60.0. When you're writing an answer to 3 significant figures, you've got to write 3 figures. So here, even though it's a 0 on the end, you've still got to write it, and that's correct to 3 significant figures. All right, let's have a look at this bearings question here. So pause the video and give this question a go. Okay, so let's read the question here. Jodie is riding her bike to school. She travels 7 kilometers east. Okay, let's remind ourselves of northeast, southwest. Northeast, southwest. So she travels 7 kilometers east and then 5 kilometers south. Okay, so it's 7 before and then 5 afterwards. Jodie's mum collects Jodie from school in her helicopter and flies straight home. Lucky Jodie. Find the distance to travel home. Well, this is a Pythagoras question, so for part A, it's going to be 7 squared plus 5 squared equals x squared. Let's work out what both of these two things are. So that'll be added together to make 74. And then we square root the answer, and we get 8.60. Just like I said before, if you're rounding to 3 significant figures, it's always got to have 3 digits in there. Calculate the bearing of the distance travelling home. So to calculate a bearing, you need to work out where you're starting, and I'm starting in this bottom right corner here, and the north line is here. So a bearing will always go all the way around the clock, as if you're a clock face, until you get to the line you want to travel on. So I think the easiest way of me working out this massive angle, which is the answer, I'm going to work out this tiny little angle in the middle of the triangle, and then do 360 minus that angle. So to work out that angle, we've got the opposite side. We're going to use trigonometry. We've got the opposite side and the adjacent side. So out of SOH, CAH, TOA, this is definitely a TOA question. So it's going to be tan minus 1. And then remember which side goes on top. It's opposite over adjacent. So 7 over 5. So let's do that all on the calculator. So tan minus 1 at 7 over 5. And we get 54.5 degrees. Now that's not the final answer. The bearing is, if you start from the angle where you start from the north line and you go clockwise around until you get to the line you want to travel on. And in this case, I'm going to need to do 360 minus 54.5. So 360 minus answer, and I get 306 degrees to 3 significant figures. Okay, so there we are. That's the answer to this bearings question here. All right, if you didn't get that, then have a go at this bearings question here. Then pause the video and work this question out. Okay, so Eric's house is 5 kilometers east of Jeremy's house. Jeremy's house is 9 kilometers south of Stuart's house. Find the bearing of Eric's house from Stuart's house. So in this question here, we see that Jeremy's house appears twice in the question. So Jeremy's house should be in the middle of our diagram. Let's remind ourselves about north, east, south, and west. So Eric's house is 5 kilometers of Jeremy's house. So Eric's will be to the east. So Eric is going to be over here. Stuart's house is 9 kilometers south of Stuart's house. So from where Stuart is, Jeremy is south of there. So Stuart must be up here. That's 9. So that makes sense because Jeremy is south of Stuart. And in this case here, Eric is east of Jeremy's house. No. I've done that wrong, haven't I? Eric is east of Jeremy. So no, Eric is on the other side here. Eric is over here. 5 kilometers. Yeah, that makes sense now because Eric is east of Jeremy, so that makes more sense. Yeah, let's connect those two together with a line. So to do trigonometry, find the bearing of Eric's house from Stuart's house. So if we're from Stuart's house, that's where we're going to begin. So that's where we'll draw our north line. And the angle we're going to need to work out is this angle round from here to here. Now, the easiest way to use trigonometry to work that one out is to call that angle x, work it out. And in this case, we're going to do 180, take away x to give us this angle round the side. So to work out x, this is the opposite side. This is the adjacent side. So we're going to be doing out of so, car, toa. We want opposite and adjacent, so it's definitely toa. So it's going to be tan minus 1. Let's get the fraction the right way around. Opposite on top, adjacent on the bottom, 5 over 9. So tan minus 1, 5 divided by 9 is 29.1 degrees. But our final answer here is going to be 180 minus 29.1. And that gives us 151 degrees to 3 significant figures. So this angle round all the way round from the north line to Eric's house is 151. Lovely, there we are. So that's the answer to that question there. Let's now move on to the next one, and we're on similar shapes now. So pause the video and give this one question a go. Okay, so the two shapes are similar, and what that means is there's a scale factor enlargement from one shape to the other shape. I'll always go from the small shape to the big shape, no matter which way around they are. So in this question, I can see that 8 and 12 are corresponding sides. So to work out the scale factor of enlargement, I'm going to do the bigger shape divided by the smaller shape. So 12 divided by 8 is 1.5. So now I know the scale factor from the small shape to the big shape is 1.5. So to work out x, I'm going to take 6 and multiply it by 1.5. So x equals 6 times 1.5, which gives 9 centimeters. So 9 is the value for x. And to get y, we need to take the 13.5 and divide by 1.5 because we're making it smaller. So y equals 13.5 divided by 1.5. 13.5 divided by 1.5 on the calculator, is also 9 centimeters just by luck. Lovely, there we are. So that's the answer for that question there. Okay, if you didn't get that one, then have a go at this one here. Pause the video and give this question a go. Okay, so the first thing we need to do is spot which two corresponding sides we can use. I can't use the top left one, can't use the bottom one, so we'll have to use this 9 centimeters and this 14.5. As always, to work out the scale factor, you do the bigger side divided by the smaller side. So that's 14.4 divided by 9, which is 1.6. So our scale factor here is 1.6. So in this question, to work out x, we're going to take 5 and multiply it by 1.6. So x equals 5 times 1.6, which gives us 8. So x is 8 centimeters. And to work out y, we're going to take the 12.8 and divide by 1.6. So y equals 12.8 divided by 1.6. And we get, that's an absolute fluky coincidence that on both questions we got the same answer for x and y, but that is right. So we get 8 centimeters as well. Right, okay, let's move on to the next question here. So this is another similar shapes question, but a real bit of a tricky one, this one. Pause the video and see if you can work out the values of x and y. Okay, so in this shape here, we've got our two triangles, one being the smaller inside triangle, and then the other triangle being the outer bigger triangle, and it's these two triangles that we're going to be comparing. So if I draw both of these two triangles out, the smaller one here and the bigger one here, let's work out the dimensions. So on the smaller one, pretty easy, it's 4, 5, 6. And on the bigger one, remember you need to take the whole line into account. So on that right hand side is a length of 15. On this left hand side, it's y plus 4. And on the bottom side, it's x. So out of these two triangles here, the two corresponding sides we can compare are the 6 and the 15. So the scale factor equals 15 divided by 6. 15 divided by 6 is 2.5. So the scale factor in this question is 2.5. So to get from 5 to x, you've got to multiply by 2.5. So 5 times 2.5 is x, which is 12.5. Lovely, 12.5 centimeters for x. And then for the, we're not going to go for y directly, we're going to go for the length of this side here. For the length of that side, it's going to be 4 times 2.5. So 4 times 2.5 is 10. But then to work out just this section here, the whole of that side is 10. So we need to take away 4. And we get 6 centimeters. Lovely. So this side here, y is 6 centimeters. Lovely, there we are. If that makes sense now, then have we go another one just to see if it really does. So pause the video, give this question a go. Okay, so again, let's draw out these two triangles, the smaller one and the bigger one. So on the smaller one, definitely goes 2, 5, 7. And on the bigger one, it's going to go 8, y plus 5, and x. So the scale factor here is going to be 8 divided by 2, which is 4. To work out x, it's going to be 7 times 4, which is 28. And to work out y, we need to do 5 times 4, which is 20 centimeters. And then we need to work out just this y side, we need to take away the 5 that we've already got. So 20 take away 5 is 15 centimeters. So y equals 15 centimeters. And there we are, that's the answer to this question here. Okay, let's do another similar question on similar triangles. So pause the video and give this question a go. Okay, so in this question here, it's a pretty tricky one to work out which side needs to go on which, needs to be comparable to which other side. If we use alternate angle facts from year 7, then we know that this angle here will match up with this angle here by z angles, because we have parallel lines here and here. And also, doing that in reverse, this angle here is equal to this angle here. And therefore also, these two angles here and here are opposite angles. So that means that the side between x and z should match up with each other. So this side here and this side here should match up with each other. So you have to work out what the scale factor is from 7 to 11.2 in this question here. Another way of thinking about it, if you're struggling on which side matches up with which other side, is if you take this triangle here and do a flippity-flip with it, then you're going to get a triangle that looks a bit like this. And let's match up our sides when we've done that flippity-flip, where x is still going on the bottom, 11.2 is going to get flipped over to this side, and 14.4 is going to get flipped over to this side. So if you find that flippity-flip method helpful, then that's absolutely great. So therefore, we definitely need to compare 7 and 11.2. So scale factor is 11.2 divided by 7. So 11.2 divided by 7 gives 1.6 again. We've had the scale factor of that before. So to get from 10 to x, x is going to be 10 times 1.6, which is 16 centimeters. And y here is going to be, so we need to go from 14.4 back to y. So y is going to be 14.4 divided by 1.6. 14.4 divided by 1.6, which gives 9 centimeters. And there we are, that's the answer for this question here. So with this sort of question here, it's all about making sure you know which two sides are corresponding. And in this sort of case, you have to go across the shape to work out which two sides were matching up with each other. Okay, let's have a go at the next one then, just to see if that made sense. Pause the video and give this one a go. Okay, so let's take this triangle here and do a flippity flip with it. So now it's over here and it's now looking a bit like this. So the 6 centimeters here, 8 centimeters here, and 10 centimeters is here. So I can tell now that the 6 and the 13.5 match up. So our scale factor is going to be 13.5 divided by 6. And getting my calculator, 13.5 divided by 6 is 9 over 4, or 2.25 as the scale factor. Okay, so now to work out x, I need to multiply 8 by 2.5. 2.25, I mean. So times 8, and we get 18 centimeters. And to work out y, it's going to be 10 times 2.25, which gives 22.5 centimeters. And there we are, that's the answer for that question there. Alright then, a couple more problem solving questions before we finish the video then. Pause the video and give this one a go. Okay, so in this question here, we need to work out the area of the triangle. To work out an area of a triangle, it's always base times height divided by 2. But in this question, we know the base is 20, we don't know the height. So first of all, we're going to work out the h height. We can't use this 20 because 20 goes all the way from left to right, but we are going to use this right angled triangle here to work out the height. So in this question here, we have the hypotenuse side and the opposite side. So we're going to be using sine to calculate this. Sine 38 equals the opposite side divided by the hypotenuse. Work out what sine 38 is, and you get 0.616 equals h over 12 times the 12 to the other side, and you get 7.39 as your value for h. Great. Now that you know that h is 7.39, now we can do base times height divided by 2. So the area equals base times height divided by 2. So the base is 20, the height is 7.39. We're going to divide that by 2. So in my calculator, I'm going to use answer button for this value here, because it's currently in my calculator as the answer. So do fraction button times, so 20 times answer divided by 2, which gives an answer of 73.9 centimeters squared. And there we are, that's the answer for that question there. Okay, so if that's now made sense, have a go at this question here. Pause the video and give this one a go. Okay, so we're going to do roughly the same thing as we did before. So we're going to work out the height on this triangle here and then do base times height divided by 2. So in this question here, we have the opposite side to the angle and the hypotenuse. So it's going to be a sine calculation. So sine 26 equals opposite divided by hypotenuse. We'll type in sine 26 into our calculator, and we get 0.438 equals h over 8, times the 8 to the other side, and you get 3.51 equals h. Fantastic. Now we're going to do base times height divided by 2. So the base here is 18, the height here is 3.51, and then we're going to divide that by 2. I'm going to select this value as, and say this value is answer when I type it into the calculator. So 18 times answer divided by 2 gives 31.6 centimeters squared. Excellent, fantastic. So there we are, that's the answer to that question there. Alright then, so thank you very much for getting all the way through that video. Very well done. Now here is the list of topics that's going to appear on the test. You'll note that question 12 here requires you to know the area of a trapezium and to do some problem solving with that. So make sure you know the formula for the area of a trapezium. And you'll also note that questions 13 and 14 are retrieval practice from previous topics. So make sure you've been doing those online quizzes to make sure that you are up to date with all of the topics that we want to keep fresh in your mind. Okay, so there we are. Thank you very much for watching that video, and I hope you found it helpful.